Welcome back, Algebra 2 students, to another Regents review video. This is the Algebra 2 Common Core exam for the June 2017 administration. This one was a challenging exam, so these are going to be the solutions to Part 1, questions 1 through 12 of this exam. As usual, before we begin, do not cheat off of this video. It is so not worth it. You have to try the problems by yourself first, then you come here to check your answers. Because as you will see very shortly, these questions can get very challenging quickly. Make sure to hit that subscribe button down below. Consider becoming a patron on my Patreon page and visit my website at www.nysmathreadersprep.com for more math content in Algebra 2. Yes, I can talk really fast. And make sure that you get the TI Inspire CX calculator. That link could also be found on my website. All of these links can be found in the description below. Without further ado, let's begin this exam. Starting off with question number 1, we are starting off with an easy question. Number 1 says the graph of the function p of x is sketched below. Which equation could represent p of x? So here's what they're testing your knowledge on. They give you a graph. You got to find the roots. The roots is a fancy word for where the whatever function you're working with crosses the x-axis. Then they give you the equations in factored form. So they're testing your knowledge on whether or not you could put a root in a binomial factored form. So let's analyze this graph here. The root for this one is x is equal to -3 because that's where this crosses the x-axis. That's x equals -3, okay? This is x equals 2, okay? And this is x equals 3. So what you should be thinking of, what are the factors? Well, the factor to produce the root of x equals -3 is the factor x plus 3. It's just the opposite of what's given. The factor that gives you x equals 2 is x minus 2. And the factor that gives you x equals 3 is x minus 3. You might be sitting there thinking, wait, how are you getting these and why are they the opposite? Well, I'll show you. If you take all these factors, right, and you set everything equal to 0, you get the opposite values, okay? You get x equals -3, x equals 3, and x equals 2 when you take the factors, which are the opposite of the numbers, and set it equal to 0. So now what we need to do is we're actually looking for this equation in our answers. We're looking for this. That's p of x, okay? So if you look down here, none of them look like that. If we look here, well, the problem is they were sneaky here. They said, okay, x plus 3, x minus 3 can be condensed using the backwards of the difference of two perfect squares. Well, you need to know if you do the difference of two perfect squares backwards, that will produce x squared minus 9. So p of x can actually be rewritten as x squared minus 9, x minus 2. And your answer for this one's going to be choice 1 for that question. Not a bad question. They just were a little sneaky with how they rewrote that answer. Number 2, what is the solution to 8 times 2 raised to the x plus 3 equals 48? Okay, so what we're going to do is we need to divide by 8 first because we got to solve for x. And what you should be thinking right now is, wait a minute, I cannot have an x term in the exponent. Somewhere along the way, you're going to have to use log or natural log. So we're going to divide by 8. Divide by 8. Okay, so we get 2 raised to the x plus 3 is equal to 48 divided by 8 is 6. Okay, move this whole exponent, the x plus 3, down in the front of the 2. So now we get x plus 3. The minute you move an exponent down with an x, you need to write ln or log. You're going to see very quickly why I chose ln because all of your answer choices are in ln. Ln and log essentially mean the same thing at your level, okay? So x plus 3 natural log of 2 equals the natural log of 6. Okay, well now all we got to do is divide by the natural log of 2. Divide by the natural log of 2. Okay, and we get x plus 3 equals the natural log of 6 divided by the natural log of 2. Now we just need to subtract that 3 on both sides. And we get x equals natural log of 6 over natural log of 2 minus 3. Your answer is choice 1. Now let's just say you don't like the way I did that question. Very simple solution. Go to your graphing calculator. Go to your calculator page. You're going to go to menu. Click on algebra. Click on numerical solve. And you're literally going to type in 8 times 2 raised to the x plus 3 equals 48 comma x. Yeah. And that gives you negative 0.415. Now what you're going to do is you're going to type in your answer. The natural log of 6 divided by the natural log of 2 minus 3. And that gives you the same answer. So you know you got it right. Perfect. All right, moving on to number 3. Cheap and fast gas station are conducting a consumer satisfaction survey. Which method of collecting data would most likely lead to a biased sample? So bias means something doesn't seem right, okay? So if we look here, which method would most likely contain a bias? Choice 1 says interviewing every 5th customer to come into the station. Well, every 5th customer is a random selection. That's good. It's a random selection, so it's not choice 1. Interviewing customers chosen at random. Again, it's chosen at random, so that's fair. Interviewing customers who call the 800 number posted on the customer's receipts. So this, ladies and gentlemen, is a bias sample because you're only surveying the people who call the 800 number. Now, chances are, if you're calling the 800 number, you are probably complaining about the service. Chances are you're not calling to say, hey, I had a great experience, because most people don't do that. You call the 800 number if you have a complaint. Okay? Choice 4 says interviewing every customer who comes into the station on a day of the week chosen at random. Again, that's that randomness. So your answer for this one is choice 3. Moving on to number 4, the expression 6xi to the third times negative 4xi plus 5 is equivalent to what? So all that you're going to do is take the 6xi to the third and you're going to distribute into your parentheses. Boom, boom. 6 times negative 4 is negative 24. X times x is x squared. I to the third times I is I to the fourth. Okay? And then 6xi to the third times 5 is plus 30xi to the third. Okay? Now what we need to do is simplify our I squared terms. Okay? So we got to simplify that I to the fourth, and we got to simplify that I to the third. Well, I to the fourth is equivalent to the answer of 1. So we have negative 24x squared times 1 plus 30x. Now the I to the third power, that's just going to be negative I. And all of these numbers here, the I to the fourth and I to the third, can be found on your graphing calculator. You actually just go to your I button and you can plug in those exponents. You will get the answer. So 1 times anything is just itself. So that's just negative 24x squared minus 30xi. You just move that negative out front. And ladies and gentlemen, that is your answer to that question. Your answer is choice 2. And that's it. So I have to do with that question. Unfortunately, you cannot type this into your calculator because there's x's in there, and your calculator gets all confuzzled and doesn't know what to do with those x's in your calculator. Moving on to number 5. If f of x is equal to 3 times the absolute value of x minus 1 and g of x equals 0.03x to the third minus x plus 1, an approximate solution for the equation f of x equals g of x is what? So basically what we're doing is we're taking these equations and we're setting them equal to each other. So this, oops, I don't know why that highlighter does that. So this equals this. Well, here's the thing. It says approximate solution. So what you should be thinking is you can't solve this by hand. You need to go right to your graphing calculator. So let's go to our graphing calculator, okay? Go to your graph page, type in 3 absolute value of x minus 1, okay? Put that in, and we have 0.03x squared. No, sorry, to the third. My apologies, to the third. Minus x plus 1. So if we graph these, it seems like we have one. No, I'm sorry. Wait a minute. Hold on a second. I just graphed that absolute value one wrong. That minus 1 should be on the outside. Okay, there we go. That's better. Okay, so there's clearly 2 intersection points that we see, but if you go to menu, analyze graph, no, I'm sorry, menu, window zoom, zoom fit, it actually shows a 3rd intersection point way up here. So what we got to do is go to menu, analyze graph, intersection, click this one over here. There's 1 intersection point, and you got to do it again. Click, click. And you got to do it one more time. Analyze graph intersection, click, click. So here's the thing, folks. Here's the thing. If you go to your answers, we have just numbers by themselves, and then we have coordinates. When it says f of x equals g of x, you have to understand what they're asking you. They are only asking for x values, not the coordinate, okay? They're only asking for x values, not the coordinate. So what we got to do is take a look at our x values, okay? So if we go back to our graphing calculator, we have all this stuff. This is rounded, so what I'm going to do is I'm going to right-click on my calculator. By doing so, you just do Control Menu if you want to do that, but I need to change my attributes. Attributes just means how many decimals are following. Click on the green arrow, and it fixes it for you. So this is actually 11.29 when you round that 8 upwards, and then all of these are just perfect. So if you look here, your answer is either 1.96 or 11.29. Obviously, 11.29 is the only answer that's there. Your answer is choice 2. The reason why these, again, can't work, they're not asking you for coordinates. They're asking you specifically for the x value. Okay, so these are automatically wrong. So your answer is choice 2. Moving on to number 6. Given the parent function p of x equals cosine x, which phrase best describes the transformation used to obtain the graph of g of x equals the cosine of x plus a minus b if a and b are positive constants? So that's really important here, that they tell you that a and b are positive constants. And the reason why is this. Inside the parentheses that you see here, this is a horizontal shift, okay? And remember, a horizontal shift is always the opposite of what you're doing. So if it's a positive number, you think you're going to the right, you're actually going to the left, and then vice versa. So there's a horizontal shift, and over here, that b is a vertical shift. So what this is telling you is that since these are both positive constants, that negative remains negative. Because if they said that they were negative constants, 2 negatives would give you a positive, so that would change the whole problem. So here's the thing. This is going to be a horizontal shift. Now, since a is positive, that stays the same. So there's a horizontal shift to the left, by a units. However many a units that is, because the shift direction is opposite the sign. I'll say that again. The shift direction is opposite the sign. So the vertical shift, on the other hand, it's a vertical shift down by a units, okay? And the shift direction is the same as the sign. So we're looking for that answer. Left by a units, down by b units. Your answer is choice 4 for that question. All right, that's how you do number 6. Pretty simple stuff so far. It's going to get a little bit trickier, but we'll talk about it when we get to it. Number 7, the solution to the equation 4x squared plus 98 is equal to 0 is what? So here's the thing that you should be thinking about. It's significantly easier if you move that 98 over to the right-hand side, divide by 4, then take the square root. Because if you do the quadratic formula, it's going to get messy, and it's really just easier to move that 98 over. So we have 4x squared plus 98 equals 0. Move that 98 to the right-hand side. Now it's just a simple, it's really just a simple like two-step equation, maybe 3. All right? So we have 4x squared equals negative 98. Now we're going to divide by 4, okay? So now we get x squared equals negative, I'm going to simplify that fraction, 98 over 4. We get 49 halves. Okay, so we got negative 49 halves. Now we're going to take the square root of both sides. Okay, so we get x equals plus minus the square root of negative 49 over 2. So now we need to simplify that garbage. Now here's how you simplify this radical, folks. The square root of negative 49 over 2 can be rewritten as plus minus the square root of negative 49 divided by the square root of 2. You could actually take that radical and apply it to both the numerator and the denominator and get it like this. Now, we know what the square root of negative 49 is. We know it's an imaginary number as well. So this is going to be x equals plus minus 7i, because the square root of 49 is 7. The square root of negative 1 is I. So we have 7i divided by radical 2. Okay? Now, we're almost there. You could rationalize. Remember, rationalization is where you cannot have a radical in the denominator because it's really just not normal procedure to keep it in the denominator. So we're just going to rationalize it. So we get plus minus 7i radical 2 divided by, now rad 2 times rad 2 is the square root of 4. Square root of 4 is 2. And that, ladies and gentlemen, is your answer to this question. Plus minus 7i rad 2 all over 2. Your answer is choice 4 for that question. All right, not too bad. Moving on to number 8. Which equation is represented by the graph shown below? Okay. Clearly, this is going to be a cosine curve, which all of our answers are a cosine because it doesn't start at the origin. So we know that. Remember that the cosine curve is y equals a cosine b of x. That's typically what it is without the horizontal vertical shifts. The amplitude, which is the distance from the midline up or down, so the amplitude is 0.5 or 1/2. Okay, so we have y equals a half cosine of, okay, now what's b? B represents the frequency, okay? And remember what the frequency is. The frequency is how many times the curve occurs in 2 pi radians, okay? So clearly it's starting up here. This is one cosine curve. Go down, then back up. This is one cosine curve. So you see how one cosine curve occurs in pi radians? Now pi is 1/2 of 2 pi. And we know that the window is usually from 0 to 2 pi. So if this is pi, we know that there's one more curve to the right to get to 2 pi radians. So the frequency is 2x. So that your answer is going to be choice 1. Now let me show you on the graphing calculator just to double check you're right. Go to your graph, type it in. 1/2 cosine of 2x. Okay? Zoom in appropriately. If they tell you pi on the graph, go to pi on your calculator. So menu, window zoom, window settings. Your x-min is negative 0.5. Your maximum is 0.5. No, I'm sorry. I did that wrong. Your y values should be negative 0.5 to 0.5. And your minimum value for x is 0, and your maximum value for this is pi. Click OK. And clearly, we got it right. There's one cosine curve on our graph page on the calculator, and there's one cosine curve here. Great. Your answer is choice 1. Moving on to number 9. A manufacturing company has developed a cost model C of x equals that ridiculous polynomial, where x is the number of items sold in thousands. The sales price can be modeled by S of x equals that. Therefore, the revenue is modeled by Rx equals X SX. Okay. The company's profit, P of x equals R of x minus C of x, could be modeled by what? All right, we got to take it slow here, peoples. Here's what we got to do first. First and foremost, we got to find the revenue function. Okay, we're trying to find the profit. It's always revenue minus expenses or revenue minus cost. Profit is how much you bring home. Revenue is how much money you earn. Cost is how much the thing actually costs to do. All right, in this case, they're manufacturing something. So the revenue function, it's x times S of x. So we're going to take S of x and we're going to multiply it by x. Okay, so the revenue function, R of x, is just going to be x times this minus 0.01x. Now when we distribute that x, we got 30x minus 0.01x squared. Okay? So we're going to take this piece right here. We're going to take this function, and we're going to subtract this from it. Okay? So it's revenue minus cost. So let's go ahead and do that. It's going to be a little messy, but I'm going to try to do it as neatly as I possibly can. So P of x equals 30x minus 0.01x squared minus, in parentheses, watch your signs here, 0.15x to the third plus 0.01x squared plus 2x plus 120. We're going to distribute that in. So we get P of x equals 30x minus 0.01x squared minus 0.15x to the third minus 0.01x squared minus 2x minus 120. Now we're just going to combine like terms. The 30x combines with the negative 2x. The negative 0.01 x squared combines with the negative 0.01 x squared, and that's all we got. So now we just write it in descending power order. P of x equals negative 0.15 x to the third. The green combinations gives you negative 0.02 x squared. 30 minus 2 is positive 28x, with that minus 120 at the very end. Ladies and gentlemen, that is your profit function. So that is going to be choice 2. That matches up very nicely. Moving on to number 10. Oh God, I have to explain this. Fine. Okay. We'll be okay. This is actually, on the Regents, this was a one-page question. So I'm going to try to explain this as best as I possibly can. Here we go. A game spinner is divided into 6 equally sized regions, as shown in the diagram below. For Miles to win, the spinner must land on the number 6. After spinning the spinner 10 times and losing all 10 times, he's very unlucky, Miles complains that the spinner is unfair. At home, his dad ran 100 simulations of spinning the spinner 10 times, assuming that the probability of winning each spin is 1 out of 6. Well, that makes sense because if there's 6 sections, 6 is only of one of those. He has a 1/6 chance to win that 6. The output of the simulation is shown in the diagram below. Okay, so this is the real life example. Again, they do this all the time. I said in previous videos. They always make some real life example and then they compare it to some ridiculous computer model. Yeah, like the computer model's always right. Whatever. Which explanation is appropriate for Miles and his dad to make? Okay. So I'm going to highlight a couple keywords that you need to know here. At home, his dad ran 100 simulations. So there's actually 100 little dots. I don't want you to, well, you actually, believe it or not, you need to count all these little dots slowly. That's what I did at least. Okay, and spinning the spinner 10 times, and this is the important piece. The probability of winning each spin is 1 out of 6. Okay? So just to save a little bit of time, I'm actually going to tell you how many dots there are on each. There's 19 dots here. There's 19 dots here, 26 dots, 31 dots, 15 dots, and 9 dots. All right, and I'm going to draw a somewhat curvature type of thing here. So you see how there's a high concentration of winning, the proportion of 6s of 0.10 and 0.2. These are just percentages, okay? So now I want to take a look at this box. The mean is equal to 0.157. So that means that the mean is really, really close to 1 out of 6 because 1 out of 6 is equal to 1.66. Now, no, I'm sorry. No, 0.166. My apologies. 0.166. Now, that is really close to 0.157. So we know that this graph that they gave us is a pretty good estimate just because the mean is very close to the probability of winning a 6. Okay? So these are really close together. Okay. Which explanation is appropriate for Miles and his dad to make? Okay. I'm going to take this slow here. What I'm going to do is I'm going to show you 2 ways that I did it. I said to myself first, let's calculate where the mean is. So the mean is 0.157. Okay? What I'm going to do is I'm going to calculate the mean plus 1 standard deviation to the right and to the left by the mean minus 1 standard deviation. Because they tell us a standard deviation. If you take 0.157 and you subtract 1.109, you get the answer of 0.048. And if you add 1 standard deviation, you get 0.266. Well, what in God's green earth does that tell us? Well, that tells us that 1 standard deviation is right around here. Now, if you're noticing very quickly what I'm noticing, you're on the right track. This shaded region is 1 standard deviation. Okay? So, if you then take the mean, 0.157, and go to the mean plus 2 standard deviations, and you go backwards, the mean minus two standard deviations, you get the answers of 0.375 and 0. Okay? So now we have a little bit of a situation here. This is the remaining standard deviation, and notice how 0.375 ends like right around here. Okay? So that's two standard deviations. Okay? Let's take a look at all the answer choices now. The spinner was likely unfair since the number of 6 failed to occur in about 20% of the simulations. Well, that's not true, because the number 6 did occur about 20% of the simulations, because there are 19. That's why I said you need to count the dots. If you take 19 dots, or the 19 occurrences, and divide it by 100, that's 0.19. That's very close to 20%. It's just 1% off. So it might be unfair, but that's a wrong reason. The spinner was likely unfair since the spinner should have landed on the number 6 by the 6th spin. That is just bogus information. You could get a 6 on the first spin, or the second, or the third, or the fourth. Doesn't mean that it has to land on the 6th spin. Why couldn't it land on the 8th spin? Right? That's just ridiculous information. Choice 3. The spinner was likely not unfair. Okay, here's the thing. Likely not unfair, meaning it's fair. That's what that means. The spinner, so I'm going to replace that. The spinner was likely fair since the number of 6 failed to occur in about 20% of the simulations. The spinner was likely fair because the number 6 failed to occur in about 20% of the simulations. So, again, the number 6, again, 19 over 100, that's equal to 0.19. That's very close to 20%. So here's the thing. The spinner is fair because the number 6 failed to occur in about 20% of the simulations, meaning that what happened is Miles doesn't have an unfair spinner. He actually has a fair spinner because on the graph they showed you, it's normal for the number 6 to occur 0 times. It's normal for the 6 to occur 20% of the time. So unfortunately, Miles was unlucky he's in that 20% of people who don't get the number 6. Okay? And that's completely normal as shown on the graph. I think this question was a little ridiculous, but the answer is choice 3, just for the sole fact that the number 6 can occur no times 20% of the time. And choice 4 makes no sense either. All right, so your answer for that question is choice 3. I don't know who was writing this question, but they are mean to children. All right, number 11. Which binomial is a factor of x to the 4th minus 4x squared minus 4x plus 8? So, here's what I would do. I would attempt to group factor first. Yeah, I would attempt to group factor first. If we take x to the 4th minus 4x squared minus 4x plus 8, let me try this first. So we're going to group factor this and this. Take out an x squared, we're left with x squared minus 4. Take out a minus 4, we're left with x minus 2. Okay. Now we could factor this to x plus 2, x minus 2. We're going to combine these to x plus 2, x minus 2. And no, unfortunately we can't do that, because the problem is this has to be the same as this. So we can't do that. I mean, here's the thing. You can group factor. It's complicated, but I don't want to show it to you. I know you could definitely group factor on this one. But what you're going to do basically is you're going to get the roots. Very simple stuff. Take the roots and use the remainder theorem. Ooh, I said that term in the past. Remainder theorem. So you're going to take the roots, which is x equals 2, x equals negative 2, x equals 4, and x equals negative 4, and you're going to plug it in to the original, and you're going to see if it has an output of 0, because remember, in order for the binomial to be a factor, the remainder has to be 0. Take x equals 2 and plug it in. So x equals 2. We get 2 to the 4th minus 4 times 2 squared minus 4 times 2 plus 8. We get 2 to the 4th. 2 times 2 is 4. 8. What is that, 16? Yeah, 16. Minus 4 times 4 minus 8 plus 8. So that just cancels. 16 minus 16. That equals 0. 0 equals 0. Check. Therefore, x minus 2 is a factor of that equation just by the remainder theorem. Pretty simple stuff. Moving on to the last one, number 12. Given that sine squared theta plus cosine squared theta equals 1 and sine theta equals negative radical 2 over 5, what is a possible value of cosine of theta? So I think this is on a previous exam as well, something similar to it. So sine squared theta plus cosine squared theta equals 1. This actually could be rewritten as sine theta squared plus cosine theta squared equals 1. I don't know who decided to just throw on the squared over here and not make it like this, but whatever. So they tell you what sine of theta is. It's this. So what we're going to do is we're going to plug in sine of theta down here. And we're going to solve for cosine theta. So we have negative radical 2 over 5 quantity squared plus the cosine of theta quantity squared. We don't know that is equal to 1. Now, I'm going to convert this to a decimal for you. This is 0.08 plus the cosine of theta squared equals 1. Subtract the 0.08 on both sides. Okay, we get the cosine theta quantity squared equals 0.92 when you subtract it. Now take the square root to find cosine. Take the square root, you get the cosine of theta is equal to 0.9592 when you plug that into your calculator. But all of your answers are in radical form. So what your job is to do is to basically take all these answers, plug them into your calculator, see which one matches 0.9592. I'm going to save some time. Your answer is choice 2, but just to show you, the square root of 23 divided by 5. 0.959 rounded up, 0.9592. Your answer is choice 2. Ka-ching. We're all done with that question, and that is the conclusion of this video. I hope that it helped you. The multiple choice for those were not that bad. I think it gets a little bit harder down the road. Make sure they hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate the support. This channel could be going for years to come, and especially expand my services into higher level math, and visit my website at www.nysmathregentsprep.com. Both of those links are found in the description below, and I hope to see you soon.